Welcome to the deep dive. Today our mission is to break down some really technical source material and pull out the core engineering.
Yep. We're looking at what it takes to hit extreme performance in modern video.
And we're doing that through just one component.
Yeah.
The PureLink TWDP-6000F-100. It's a DisplayPort 1.4 fiber cable.
And this is really a deep dive into what performance costs. I mean, you look at a 10-meter cable, and it has a nearly $300 price tag.
Wow.
And what you're paying for is reliability at the absolute edge of what's possible right now. We're talking 8K at 60 frames per second.
And 4K at 120.
Exactly, and both with that really demanding 12-bit color depth.
Okay, so let's unpack that. To get that kind of performance, what's the foundational spec, the first number you have to hit?
The threshold is 48 gigabits per second. That's the bandwidth you need.
48 GBPs.
Right, and that capacity is it's critical. It's what lets you run Ultra HD 8K at 60 frames with uncompressed 4.4.4 color.
So no compromises on the color data.
None. It's also the headroom you need for things like HDR, high dynamic range, and ARC, the audio return channel, without any compression.
Okay, so hitting 48 gigs is one thing, but sustaining it over a 10-meter run, that seems like the real engineering problem. Why can't a normal copper cable do that?
Yeah, that's the thing. Signal loss. Over copper at these frequencies and that distance, it just becomes, prohibitive.
It just degrades too much.
It does. And that's why the sources point to a major shift in materials. They use high-tensile fiber components, not copper, for the main data path.
To keep that signal pure over the distance.
Exactly. And to fight off any kind of interference, they use triple shielding. That's for superior noise immunity, which is just essential when you're pushing these data rates.
But I'm curious, if the main signal is on fiber, why do the specs make such a big deal about the 24K gold-plated contacts? Aren't those copper?
That's a really sharp point. It's because the connection points, the termini, still need robust power and low-speed data exchange, and that's where the gold contacts come in. But the bigger insight here is all about physical reliability. I mean, just look at the connectors themselves. They call them SLS, the secure lock system.
The retention force on those it's kind of staggering. The specs say they're designed for up to 15 pounds of force.
15 pounds.
Yeah. That's not just a snug fit. That's engineered to not fail. To prevent disconnects in, say, a server room or a high-end installation where unplugging is not an option.
And that, plus the lifetime warranty, tells you this is for mission-critical work.
Which actually leads us right into the most interesting part of the specs, the technical nuance.
The product is marketed as a DisplayPort 1.4 cable, right?
Right.
But if you dig in, the specs explicitly say it's compliant with HDMI 2.1. In fact, the input connector type is listed as HDMI 2.1.
So wait, it's a DisplayPort cable that speaks HDMI. What does that mean for the industry?
It signals a huge shift. It suggests that the performance ceiling, that 48 GBPs number, is becoming the real standard.
More important than the name on the connector itself?
Precisely. This one cable has to manage compliance for DP 1.4 for the high-speed parts of HDMI 2.1, and on top of that, it has to adhere to every single version of HDCP content protection.
So 1.3, 1.4, 2.2, 2.3, all of them?
All of them. And it's also TAA compliant, which means it can be used in U.S. government systems. The target here is clearly complex, secure, professional setups.
So if we connect all these dots, the key takeaway for you, the listener, is that reliable 48 GBP's 8K video isn't just about one thing, it's a whole system.
It is. It demands specialized fiber, extreme shielding, and, these almost over-engineered physical locks like the 15 pounds of force.
Which leaves us with a final thought.
Yeah. Given the price and the fact that this cable has to meet both DisplayPort and HDMI specs, is the future of high-performance cabling defined less by the protocol name and more by that raw bandwidth requirement, that critical 48 GBPs number.
And the physical locks that guarantee it won't fail. What other component in your system demands that level of security just to keep it plugged in? Something to think about.